Hey, so we're going to do some more practice with quadratics today. So I have a few examples pulled from the EDA assignment you're going to have to do. Um, so I'm going to go through not one as many as you'll have, but a couple from each type. So this first one, it wants to solve for C, and we're supposed to be using the square root property to solve for this. So when we want to solve by square root, what we want to do is want to get whatever thing is being squared by itself. So that, in this case, that's the C. The C is the only thing that square is applying to. Um, if it was like that, then it would be to the 4C, but it's not. So it's just on the C. That's the only thing we want we want that C squared by itself. So like always, first thing we need to do is get rid of any other terms. So we're going to subtract 4 from both sides. And that gives us 4c squared equals 25. Then the only thing else that's with that c squared is this 4, and they are right next to each other. That means they're multiplying. So to get rid of that 4, we need to divide by 4. And that will give us c squared equals 25 fourths, right? And then last thing we want to do is we want to get the c completely by itself. Right now it still has the square. So how do we get rid of the square? We take the square root. If we do it to one side, we have to do it to the other. So the square root of c squared is c. And over here, we can evaluate the square root of 25 over 4 because we can do the square root of 25 divided by the square root of 4. And then the square root of 25 is 5. And the square root of 4 is 4. Excuse me, square root of 4 is 2. Now, remember, whenever we solve by using the square root, we're going to have a plus or minus. So one of our answers is going to be c equals 5 halves, and the other answer is going to be c equals negative 5 halves. Right? Slide on down to the next example. So this one, it wants us to complete the square. So it says solve by completing the square right here. So if you remember, completing the square is where we make it a perfect square trinomial, and then we use that to rewrite it, and then we can solve using the square root property. So I have k squared minus 10k minus 9 equals negative 6. So the first step with these is to move whatever c value we already have to the other side. And that gives us k squared minus 10k plus something equals negative 6 plus 9 would be 3, right? And then we take this b value over to the side, and we say 10 divided by 2 is 5, and then 5 squared is 25, and that is what we put here. So we're going to do k squared minus 10k minus 10k, and then we're going to add 25. Now, if we add 25 to one side, we have to add it to the other side. So now we have k squared minus 10k plus 25 equals 3 plus 25, and we can rewrite that as 28, right? We can combine those like terms. Now, we have a perfect square trinomial because we can rewrite this as we can take the square root of the first term, so k squared is k. We can take the sign here, that negative sign. That's that. We can look at negative minus. All right, and then we can take the square root of the third term, which is 5. All right. The reason we can do this is if I write this out again, because we're gonna set it squared. If I write this out again, pretend we didn't square it. If I did k times k, I get k squared. If I did k times negative 5, I get negative 5k. And did negative 5 times k, I get negative 5k. And then negative 5 times negative 5, I'd get positive 25. So then I have k squared minus 10k plus 25, which is what we already have. So that's why we can rewrite this as as k minus k minus 5 squared, because it's equal to it. It's the same thing. That's why that we call that a perfect square trinomial. So we have k minus 5 squared equals 28. Now, like what we had up top, we have just the thing that's being squared by itself. Now this time it is a binomial instead of just a number, but we can take the square root of it, and we can take the square root of the other side, and that gives us k minus 5 equals the square root of 28. Now this time 28 is not a perfect square, so we need to come over to the side and do our factor tree. So 2 will go into 28 14 times, and then 2 will go into 14 7 times, and so that gives us a pair we can pull out. So we have k minus 5 equals plus or minus 2 square root of 7. And then to finish this, we need to add 5 to both sides, and that gives us k equals 5 plus or minus 2 square root of 7. And that's our answer for that one. All right, next one, you're supposed to solve using the quadratic formula. I want you to pause the video and try to write that down without any help first. So go ahead and do that. And then after you do that, hopefully this is what you wrote down. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, remember our a goes with our quadratic term, b is with our linear term, and c is the constant. So we have x equals negative 11 plus or minus the square root of 11 squared minus 4 times 4 times negative 2 all over 2 times 4. We have x equals negative 11 plus or minus. We've got 11 squared can give us 121. And then negative 4 times 4 is going to give us negative 16. Times negative 2 is going to give us actually a positive 32. Then that's all divided. Oh, let's not cross out that. All divided by 8. So then negative 121 plus 32 would give us 153. So I have x equals negative 11 plus or minus square root of 153 over 8. And then let's see if we have any factors for 153. Obviously 2 won't go into 153. Let's see if we do 3. 153 divided by 3 would be 51. And then 51, we can go 3 into that. Not 13 times. That would be 51 divided by 3. 17 times. All right, so I can pull out a 3. That leaves us 17. So I have x equals negative 11 plus or minus 3 square root of 17 over 8. All right. Last one, it wants to determine the number of real solutions. Okay. So remember, I should go 2 more. Remember, when we determine the number of solutions, all we need to look at is the discriminant. So we have that quadratic formula. Remember, the discriminant is this part right here is underneath the radical. So if we evaluate the discriminant, we have b squared minus 4ac. That's the discriminant. If that is a perfect square and bigger than 0, then we're going to have two real rational solutions. If it's bigger than 0 but not a perfect square, then we're going to have two real solutions. And then if it is equal to 0, we're going to have one real solution. And if it is less than 0, we're going to have two imaginary solutions. All right. So we look at the question again, now that we talk about that, it does say they're all going to be real. So if you get a negative number on this, then you've made a mistake, because it's telling us that you should have a real, so at least real solutions. So there should be no negative numbers underneath that square root. So you need to take b squared, which would be negative 220 squared, minus 4 times a times c. So then, if you do that in your calculator really fast, you have negative 220 squared minus 4 times 100 times 121. And you get 0 for that one. So that means this is going to be 0, so that means this is going to be one of those where it goes like this, and it touches, but it doesn't go cross through it all the way. You have one intersection, but it doesn't go past it. All right, and then the last one, we have solved the quadratic equation for n in simplest form. So we want n, we want the roots for this quadratic. So what we can do is we can use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have x equals negative 1/12 plus or minus the square root of 1/12 squared minus 4 times 1 times negative 1/12 all over 2 times 1. All right, so I have x equals negative 1/12 plus or minus square root 1/12 squared is going to be 1 squared, which is 1, and 12 squared, which is 144, minus, we'll have negative 4 times 1 is going to be negative 4, and then negative 4 times negative 1/12 is going to be positive 4/12, which would actually be positive 1/3. And then that's all over 2. Have x equals negative 1/12 plus or minus 1/44 plus 1/3 is going to be 49 over 144, and it's all divided by 2. And then I can take the square root of 49 over 144, because it's going to be 7 over 12. So I have x equals negative 1/12 plus 7 over 12 all divided by 2. Or I have x equals negative 1/12 minus 7 over 12 over 2. All right, so I'm going to jump up here to keep going. So negative 1 plus 7 would be 6/12 over 2. So that would be x equals 1/2 divided by 2 will be the same things as times 1/2. So x equals 1/4. And then on the other side, I have x equals negative 8/12 divided by 2, which would be negative 2/3 divided by 2, which would be negative 2/3 times 1/2, which would be x equals negative 2/6, which would be x is negative 1/3. So those are your two answers, 1/4 and negative 1/3. And let me just double check myself for that one. So I have x squared plus 1/12 x minus 1/12. And I have 1/4 as one answer and negative 1/3 is the other. Yes. So that's it. All right.